All right, we'll go ahead and get started. Welcome everyone to the PocketLab webinar. Today we're going to be talking about how to use your PocketLab in lower elementary school grades. So lower than middle school. How do we get PocketLab? Can you use that in middle school? And we're going to talk, in elementary school. And we're going to talk specifically about this idea about what is the story that your graph can tell. How can you measure things that you can't see and measure that with a graph and then get that graph to tell you a story about something to do with the world around you and to explore the world around you. So that's kind of the theme of what we're talking about today. I'm going to be the main presenter, so I'm Robbie Douthit. I'm the Director of Curriculum and Community Engagement here at PocketLab. And then on chat support today is David Baker, our COO and co-founder here at PocketLab. So as we go through the webinar today, if you have any questions, put them in the chat, and Dave will either answer them in the chat, or he may wait and we'll go over the questions at the end. So we'll also do a questions and answers section at the end as well. So I'm going to go over our agenda really quick. One thing to note as well, at the top of your screen, you should see a coupon code that you get for being a part of the webinar today. So it's a $10 coupon code for orders of $100 or more on our store, and that lasts for about a week. So you can see the code up there. It's webinar, and then today's date, 8/15/19. So use that code for your $10 coupon code. It'll be up there throughout the webinar. And then at the end, we're going to do a raffle as well. So make sure you stick around to the end so you can check out the raffle. Okay, our agenda today, we're going to talk a little bit about our mission here at PocketLab. Then we're going to talk about the basics of PocketLab and how to get connected, using the PocketLab app, recording and reviewing data. And then we're going to talk about using PocketLab in the classroom, talking about two kind of things, using PocketLab as a weather station to tell the story of your classroom. So actually putting a PocketLab inside your classroom and using that to figure out different things that are happening in your classroom and how the graph can tell that story. And then taking PocketLab out into the field and finding the hidden story in an environment. So we're going to talk about heat islands with that and how you can do some really interesting environmental science and earth science activities with your students. So at PocketLab, we believe science and authentic data collection should be fun and engaging and accessible for all students. We build our PocketLab sensors to be tools that you can go out and use to explore the world around you, for students to come up with hypotheses about something they're observing, and then use their PocketLab to test that hypothesis. And that's what we want students to do with PocketLab, to engage in science and to explore the world. So we have three different PocketLab products that we're going to talk about briefly today. There's PocketLab Voyager, which can measure weather type measurements, so temperature, pressure, humidity, altitude, light intensity. And then it can also do more things for motion and physics, physical science. So it can measure things like acceleration, speed, rotation, magnetic fields. So this is a really great for if you want to put it on a car or a rocket, crash into a wall, launch up in the air, and get a lot of really interesting data for that. But then it can also do some of the weather activities and environmental activities that we're going to talk about a little bit today. PocketLab Air, this way, is our newest sensor. And PocketLab Air can do those same weather measurements. So it can measure temperature, humidity, barometric pressure, light intensity. But it can also measure things like carbon dioxide and particulate matter, which are small particles in the air. So you can measure those with PocketLab Air. And then you can also measure ozone. So this is really great for environmental science, doing investigations into climate change, air quality, even biology stuff with the carbon dioxide sensor. PocketLab Air is great for that. And then finally, the last one that we're going to use mostly today is PocketLab Weather. So PocketLab Weather measures temperature, pressure, humidity, altitude. It has a temperature probe that you can plug into the side of it. So you can put that in boiling water or an ice bath or anything like that, the temperature probe. And then it measures things like dew point and heat index as well. So our three PocketLabs here, all of the activities that I'm going to be talking about today, you can actually do with any of these three. I'm going to just kind of use mostly today in the webinar. I'm going to be using PocketLab Weather. And the basics of PocketLab is it works by, you connect your PocketLab via Bluetooth. It sends a signal, connects to our PocketLab app, which you can find on computers, tablets, and smartphones. And we have two different main types of apps. Our PocketLab web app, which you actually can just go to a website, which I'll show you in a second, the PocketLab.com/app, and then you launch the PocketLab app right from the website. And then also there's a mobile app that you download on your iPhone or iPad or Android, and you would just download it from your app store, and then it connects to that app. All of the apps are free, so there's no licensing or any cost to any of the apps. They're all free, and you can use them on just about any device. Okay, so we're gonna show you how to get connected to the PocketLab Weather, and we're going to and kind of show you the basics of the app and how to use it. And we're going to start by thinking about this idea of measuring the invisible and while we measure the invisible, getting the graph that we see to tell us a story. And so here with humidity, we're going to think about, and you can get students to do this activity in your classroom, just kind of on some basic ideas. There's water in the air we breathe. We just can't see it. So we can see a glass of water, we can see ice, but water vapor, water that's as a gas, we can't really see that. But we can still measure it with PocketLab. And so as we breathe, there's water in the air we breathe, and the humidity graph can measure how much water is in the air. So can we figure out how to measure the invisible water that's in our breath? So I'm going to start by connecting us to the PocketLab web app. I'm on a Windows 10 computer right now, but this would be the same on your Mac or Chromebook or anything you might have in your classroom. So I'm going to share my screen, and as I share my screen, it'll just take a second here, so bear with me. Okay. So you should see our PocketLab website. This is the PocketLab.com, and this is on a Chrome browser. So I've just gone to our website, and the way you get to our app is you either click the button that says app that's right here, or you can just type in the PocketLab.com/app, and then you're going to launch our app directly into your web browser. And so it's easy. You don't have to download anything. It's all right there. So if you have a class set of Chromebooks or something like that, or computers, you don't have to have somebody download all the app onto your computer. It's just you just go to the website. Then I click this big button that says Connect to PocketLab. You can't see this because of the way the screen sharing works, but a connection window pops up that lists all the PocketLabs that the computer can read via Bluetooth. So I just turn on the PocketLab, and I see it says on my screen, I can see it says PL Weather, PocketLab Weather. So I click on that and click Pair. Again, you can't see that because of the screen sharing. And now it's connecting to the app. Okay, so when I use a PocketLab Weather, the first thing I see is PocketLab up here measuring temperature, humidity, pressure, and light intensity. And then down below, we're actually pulling in data from local weather stations to your location. So here we have the barometric pressure reading in the San Francisco Bay Area, which is where we are right now for the webinar. I can change this to temperature. So right now, this is kind of the temperature. It's really hot here in the Bay Area. I'm sure across the country, I know we're having a big heat wave. So it's about 27, 28 C here. Actually in San Jose, which is where we are. Okay, so A couple things you might see. I'm measuring all these different things at once. Here at the top, this is measuring the light intensity of the PocketLab. If I cover up the PocketLab, you'll see that light intensity go way down to 0 because I'm covering up the sensor. And then I open it back up, and you can see it'll go way back up. So the PocketLab is measuring all this data and sending it in real time to the app. Now I want to measure humidity, and I just want to look at a graph of humidity. So I just go up here to where you can switch graphs. And I'm going to just switch off looking at all the measurement conditions, which is what we have selected here. And I'm going to click just humidity, and then I click done. And now I'm going to see a graph streaming of humidity data. I'm going to turn right now it's measuring 1 humidity point every second. I'm going to turn that up to 10 per second, so you can change the data rates. And then to measure the water vapor in my breath, all I have to do is breathe on it, and I can see that the graph is measuring something that's invisible to me. So again, if you're talking to elementary school students, 3rd grade students, 2nd grade students, we've had PocketLab used down into 1st grade, but just with really simple ideas of PocketLab is measuring something you can't see. I can't see the water vapor in my breath, but when I breathe on the PocketLab is giving us data about things in the world that we can't see. What I want to do next is another example of how you can take some qualitative things that you might do in your science class and make them quantitative with a PocketLab. So as an example, an activity that you might kind of do in science in elementary school is to get students thinking about how molecules and matter, how that stuff works, and how matter makes up things around us. And so one kind of thing you can do to get students thinking about that is you can take a plastic bag and fill it with air, and they can't see air molecules, but air is in there. And as they squeeze the bag, they can feel the pressure of the bag. They can feel that something is pushing against their hands as they squeeze it, and that is actually the pressure of the air molecules. So as they squeeze on the bag, the air molecules that are in there get tighter and tighter as they get more densely packed together, and they can feel evidence of that in their hands. So it's just kind of a qualitative thing you can do. What makes up air? Well, you can't see it, but you can feel it when you push on this bag, and that's because there's molecules in there that are moving around, and they tighten, they get more densely packed together as you push on the bag. So that's a qualitative kind of demonstration that you can do with students, or just a qualitative quick activity. You can get them thinking about sort of these things in the environment that they can't see. But with a PocketLab, you can make that much more quantitative, and you can actually collect real data with your students. So I'm going to do that by switching graphs from humidity to barometric pressure. So we're just measuring air pressure. And now I'm going to take my PocketLab weather, and you can do this with PocketLab Voyager or PocketLab Air, or even our original PocketLab. And I'm going to fill it up with a little more air. Okay, so now I have the same experiment, but this time I have a PocketLab inside the bag here. And I'm going to go down here where it says record, and I'm going to, when I'm ready to do my experiment, to start my experiment, I'm going to click record. And now as I squeeze the bag with different amounts of pressure, you can see that the pressure changes. And you can have students squeeze at different levels of the bag. So squeeze it harder and harder, and then squeeze it as much as you can, and then let go, and then I click stop. And now I have this graph that I've recorded of the pressure measured by the PocketLab inside the bag. And so what they're really measuring is how tightly packed those molecules that they can't see, how tightly packed are they inside the bag as you squeeze the bag. So you get this really cool graph, and you can ask students, well, where did you squeeze the bag? Where did you squeeze it more? Where did they start getting closer and closer together? And you can see each one of these little places where I squeezed the bag more and more, you saw the pressure go up. And so these are another example of something that the students can't see, something that's invisible, but something that they can measure with PocketLab. Now, a little bit more of an advanced feature is, so maybe you get to this in maybe some of the upper elementary grades, but would be things like doing some statistics, like calculating the average, or there's some more advanced features like that. If you're interested in that, I'll show you really quickly. You can zoom in on any part of the graph that you want by clicking and dragging. So let's say I wanted to zoom in on this little section of the graph. I can click and drag, and that zooms in. And then again, maybe upper elementary, you might want to find the average of this set of data that you see here on your screen. There's a data analysis button. You click on that, and you can get a mean of the data that you're seeing. So this is the mean of the data that we're zoomed in on. And then you get other stats like standard deviation. You might not want that, but it's there for you if you want, as well as the ability to fit curve lines and things like that. So that might be upper elementary, middle school, high school more, some of those advanced statistics, but they're all right there for you to use. And then I can hover over different data points with my mouse, and I get the values of those data points appear on the graph. If I want to zoom back out and look at the whole graph, I just double click anywhere, and there's my nice graph. Okay, so I will also show you just really quick that you can view multiple graphs at once, because I'm gonna show you an example of that in a little bit. But let's say I wanted to look at both pressure, light intensity, and even humidity. You can view 3, 4 graphs at once at the same time. So you just click on those. Okay, so I'm going to go back to the presentation here to go over a couple other activities that you can do in your classroom. So, okay. So we talked at the beginning about a couple things that you can do in your classroom. One is using PocketLab as a weather station. So this is just a simple, quick activity that you can do that kind of would last actually throughout the day, but it's kind of a really easy setup and something that gets, again, students thinking about how can I use PocketLab to measure the invisible, and how can a graph tell me a story about maybe what happened in your classroom. So you can what you do is you use your PocketLab as a weather station. So you take your PocketLab, you plug in the temperature probe, and then you can do this with PocketLab Voyager or PocketLab Air as well. You can do it with all 3 of them. And you just take your PocketLab and you tape it against the wall, or you put it somewhere in your classroom, but it's best when students can really see it. So as they are doing things in the classroom, they can actually look up and kind of see that this is the thing that's measuring the weather in the classroom. But you put it up against the wall, you plug in the temperature probe, and then you connect the PocketLab to your PocketLab app. And then you maybe have the class look up, maybe you put it on a monitor so you can see the different graphs that are being measured, and you talk to your class about where we're going to be recording temperature with the temperature probe, how much light is in the classroom, and then we're also going to measure humidity. So those 3 things. And humidity, again, maybe you did the activity where you breathed on the PocketLab. Humidity, again, is this invisible water vapor that's in the air. So throughout the day, you do different things, and then you pull up the screen as you're doing other activities in your classroom, and you see how the graphs are changing based on what's happening in the classroom. So while the activity maybe, you maybe start out with at the beginning of the day, you can go about your other activities like your reading or your social studies or your writing activities, and then periodically keep checking how the graphs are changing. So again, PocketLab can measure the invisible, and we can feel changes in temperature, humidity, and light intensity, but we can't see them. So you talk to that with your students about that, and how might the actions we do in the classroom affect invisible things in our in our environment? How can we see the invisible in the graphs that we record? So this, I recorded humidity, temperature, and light intensity in our offices at PocketLab a little while ago, and these are the graphs that I got. And so at the end of the day, you can go back and you can look at the graphs and say, okay, what story does this tell? What happened in our classroom that changed the graphs that we see? And so here's actually what we did in the office to get these different things. So the light intensity, I turned the light off, and then the lights came back on. I turned them back on, and you can see that changed the graph of the light intensity. Here, I opened a window, and when I opened the window, the temperature dropped for a while. Here, the humidity was kind of rising, but you can see when I opened the window, it also went up a little bit more. And then here, I actually turned the heat on, not for very long because it's hot, but I turned the heat on, and you see the temperature spiked up, and then I turned the heat off, and the temperature went down. So you could turn on the air conditioning in your classroom, turn on the thermostat, turn on fans, do different things to change the temperature in the classroom and to see how does that affect the graphs that you're seeing. So other things that might change the story of your graph: students entering and exiting the classroom. If you have a PocketLab Air, this would be you could do it with all three of them, but with a PocketLab Air, that would be especially interesting if you were measuring the carbon dioxide in your classroom, because as students come in, people are going to be exhaling, and there's going to be a lot of CO2 in the classroom as they're breathing, and you can get students to see, why does this gas change in our classroom, and where is it coming from? It's coming from us, coming from our breath. Another one that would be interesting, which I haven't actually tested this, but exercising in the classroom, have students get up and do jumping jacks and kind of get moving, and how does that maybe change the humidity or the temperature in the room? That would actually be interesting to see, how does that affect the carbon dioxide in the room, because as they're breathing more rapidly, maybe that changes how much CO2 is in the room versus when they're breathing normally. I don't know, maybe have them meditate too to not breathe, to breathe calmly, and does that affect the CO2 in the classroom? I'm not sure, but it'd be cool if somebody tried that and let us know, and we'd love to share the results. Turning the ceiling fan on and off, closing or opening the blinds, turning on the air conditioning, all those things can affect the weather inside your classroom. And so how do you measure that with PocketLab is really interesting. And then the other activity that I'll talk about is taking PocketLab outside of the classroom now and out into the field, and doing an experiment about what are called heat islands near your school. So what is a heat island? A heat island is an urban area that is warmer than maybe more rural areas due to human activities. And so when we build cities, or when we build parking lots, when we build roads, those things create what are called heat islands, and that makes areas around cities much warmer than areas in the country. Or even at a park, you'll see that the basketball courts with the asphalt is much warmer than an area with trees and with grass at the soccer field. And you can measure those differences with PocketLab. And this is really great because there's if you're doing NGSS in your classroom, there's a lot about, in environmental science, in the earth science section, there's a lot about measuring or thinking about how humans affect the environment. And so this is a really simple way to see how what we do and how we plan and how we build things can affect the environment around us. And this is an example actually of a professor at Wittenberg University who's using PocketLab. And these are actually high school students. So she wrote up a lesson plan. It's a little bit more at the high school level, the way it's written, but you can also use it in elementary school. So here's their students out with a PocketLab weather, and they're out measuring the temperature in a parking lot, and then they compared it to a park and the temperature at a park. So you take your students outside to the playground or yard, and you ask them to make predictions about where places on the playground might be warmer or cooler. And then you connect your PocketLab to the app and record temperature probe data. So what you really want them to do is predict where it's going to be warmer or cooler, because what we want students to do is to come up with a hypothesis and then use their PocketLab to collect real data that test their hypothesis. And you can and having students do that in elementary school is a really powerful thing to do to get them to really become authentic scientists. So you take your PocketLab and you compare the environment and temperatures around the playground. So then you look at, near the blacktop at the basketball courts, you go to the grass of the soccer field, under trees, other places on the, on the jungle gym, stuff like that. And you ask students, what do you notice? Where does the temperature change? And if you had to design your own playground at school, what would you do differently? So you could get them to actually design their own playground and maybe come up with things based on what they see that would help them with this issue with heat islands. So maybe they're noticing that when they play basketball, they get a lot warmer than when you're playing soccer because of the way the playground is designed. Or when you're out playing on the swing sets and everything, maybe that's very hot, but they could add more trees to the playground or add more grass, things like that. So here's an example of some data that I collected again around our PocketLab offices. This first is a picture of our PocketLab with some temperature data, and you can see that this is in the grass and it's in the shade. And it's the same day, same environment. I just moved it a few feet over to where it was no longer in the shade and it was out in the sun, and then you can see the temperature starts going way up. And then it was going up, and then actually you can see here it moved behind a cloud, and then I moved it to the road where there was where there's asphalt, and you can see right there the temperature is just way, 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 way up. So just a few feet, all these places were just a few feet away from each other, but you can see these big changes in temperature based on just the surface and the shade and things like that. So another really kind of fun activity you can do with your students. Okay, so I'm going to go over some resources that you can find to find all these different activities, and some ways that you can find lesson plans, getting started videos, everything else you'll need if you're using a PocketLab, and then we'll take some questions if we have any at the end. So I'm going to share my screen just really quick again so I can show you where to find these resources. Okay, so we're still recording our PocketLab data here that whole time. I'm going to go to our PocketLab main page at thepocketlab.com, and you'll see at the top there's a section called Educators. If you click Educators, you will be brought to our Educators page, which has literally hundreds of PocketLab activities that you can do across all grade levels. So you can see a bunch of them here. And then also at the bottom, you'll see some PocketLab in the news, some kind of exciting things that we're doing. One thing recently, here's a group of elementary school students that use their PocketLab Air to go out and measure air quality at their parking lot at their school when parents were dropping their kids off and picking their kids up. And there was a bunch of cars around that were idling, and you had buses that are idling and idling their cars. And then they measured the air quality at the parking lot, and they did it again in the middle of the day when there were no cars, so they could compare the air quality at pickup and drop off at their school to think about how you could do different things at your school to make the air quality better for all the students when they're waiting for their parents to pick them up. So that was just kind of an interesting activity. There's a little article about that on our educators page. You can search by grade level here, so you can search by elementary school if you want, or middle school, high school, AP, and college, and you can get different activities for that. A cool one that we just recently posted is a Thermos design challenge. So you can get students to build like a thermos or a cooler, and then they use the temperature probe from their PocketLab to measure the temperature changes of like maybe like water to try and keep it warm if they're building like a thermos, or an ice bath of water if they're trying to build a cooler to keep things cool. And then they use things like tinfoil. They can cut out all kinds of craft supplies, construction paper, and they try to design something that keeps either a beverage like a cup of coffee hot, or something cold like a can of soda. So that's a really cool activity you can do with your PocketLab. You'll also find some lessons about air quality. So if you have a PocketLab Air, this is a great resource. There was some curriculum that was developed by King's University and the Tellus World of Science, which is a science museum, and those are both up in Edmonton, Canada. And they developed some air quality, environmental science curriculum that uses PocketLab Air. And so they did that for both 4th grade students, 7th grade, and 9th grade students. So if you're elementary school, middle school, or high school, there are lessons for that using PocketLab Air. And here is an example of the 4th grade lesson guides. This is a great curriculum. There's a bunch of different lessons in here, all really clearly laid out how to do everything. So it's a great resource if you're using PocketLab Air. And then a couple other quick activities. This is a great one for students. What causes the seasons? So you take your PocketLab Weather or PocketLab Voyager, either one works. You plug in your temperature probe and you tape it to a globe, and then you have a light shine on it, and you can move the globe to different areas like it's orbiting and see how the light intensity changes at different angles, and then how that affects the temperature. And you get students to think about how this models the difference between summer and winter and things like that. So this is a great way to talk about seasons with your students in a real quantitative way. If you want to do some physics and moving activities, if you have a PocketLab Voyager, there's a great activity where they think about why do figure skaters, how can they spin so fast? So you have them hold a PocketLab and they can sit in a chair and actually spin in the chair and hold their arms out and then pull them in. And as they do that, they're going to see a change in how fast they spin. And they can just kind of do that to think about why figure skaters can spin so fast. So there's a great activity there. Another one that's related to the heat island one that we talked about, so you may want to do this connected with that, is thinking about color and temperature of objects. So you can take different pieces of construction paper, and you can take them outside or put them under like a heat lamp, and you lay them out on the ground, and you can then measure the temperature difference between those pieces of paper as they heat up. And you'll get the students to think about how different colors, what is color, how different colors can be different temperatures, and why that is. So that can relate to the heat island one, because you can get them to think about why a blacktop can be so hot on a really hot day in your playground. And then again, these are just some lessons. If you search by elementary school, that you'll see that would be good for the weather station in your classroom. So looking at how ceiling fans in winter can actually keep your classroom warmer, saving energy with curtains, what is temperature, things like that. Those are all some great elementary school lessons that you can do with PocketLab. And then finally, this is a little more advanced at the high school level, but this is the heat island lesson that I said that the professor from Wittenberg University, who's done a lot of really cool activities with PocketLab. This is a lesson that she wrote about the heat island, so you can get like a more in-depth look at that activity as well. I'm going to send out all of these links, as well as a link to this video tomorrow. So look out for that email, and you can see links to all the things I just showed you. So if there's one in particular that caught your attention, I will send that out. You'll get that in your email. Okay, so with that, that's all of the that's the main presentation. If there's any questions right now, go ahead and add them to the chat, and then I'll answer them. I did see that Roger earlier asked, could you use Voyager for all these activities too? Yes, you can. The PocketLab Weather, you can use PocketLab Weather, PocketLab Voyager, or PocketLab Air for all of the activities that I showed today. So every activity we did today, you can use any of those sensors for. So no matter what you have, you can do those in your classroom. Okay, are there any other questions? Okay, we did do a raffle. So there is a winner of a PocketLab Weather, and the winner was, Lori Guyan. Sorry, I couldn't remember. We did the raffle. So Lori Guyan, you are the winner of a PocketLab Weather. We'll send you an email to let you know if you're not in the, if you weren't in the webinar today live. But thank you to everyone who attended and everyone who registered. We'll send out all the information with the links to all the resources and the live and the video that was recorded here. One more thing is, don't forget, there is a coupon code that you have for attending the webinar. It's webinar 81519. You can see it up at the top of the screen. I'm going to add it to the chat as well. That will get you $10. It's a $10 coupon code that you can use this week on our store. So make sure you check that out. Okay, thanks again, everyone, for joining. We appreciate everybody being here. If you're starting up at your class, if you're a teacher and you're getting started this week or sometime in the next couple weeks, good luck with the start of the school year. Please let us know if you have any questions. We're happy to help. So thank you so much.